Okay, so this is if you're wondering what's the chapter, like what's the topic, so it's work, energy, and power. Okay, so we'll go to the first set of questions from work, energy, and power, or electrostatics as we prefer to call it. So we'll just try to go through a couple of questions related to this. So let's start with the first question. Let me start. Uh, how about I start sharing my screen again? Okay, so I'm pretty sure you guys could see my screen right now, just to make sure that you are. Yes, you are. How about I give you 5 minutes, uh, and like, uh, let me, yeah, let me just first give you 5 minutes, and you guys could try figuring out the solution, and then we would just come back after 5 minutes and try to see whether or not we are being able to solve it. Okay. So it's been taught. Just try to figure out how you can apply the knowledge that you have learned so far to figure out how to solve this like 5 minutes from now. Okay. Okay. So let's go back to the solution. Okay. Let's go back to sharing the screen. So coming back to the question that we were trying to solve over here, it's a pretty straightforward question. Try to visualize it, what's happening over here. Uh, First of all, you have a charge Q1, then you have another charge Q2. So the charge of Q1 is 10 to the power minus 6. Charge of Q2 is 2 into 10 to the power minus 6. So if I'm trying to figure out how much amount of work, so what was the equation to solve work, right? So work was nothing but force into distance, right? And there was another equation over here, if you recall. Let's just look into the equation. So first of all, look into this one and try to figure out which equation would be like the most convenient for here. If you're confused, like you know that this is the equation that you have. Like one is charge, uh, P1 by P2, O and E. Okay, so now coming over to the question over here, amount of work done to bring a charge Q1 from P1 in the presence of another charge P2. Okay, so over here, like the first thing would be to figure out the distance. Like, how do I figure out that distance? So for those of you who do not know how to figure out distance, it's usually given like this: x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square root over. Okay, so in this case, it's 2 minus O whole square plus O plus O. So obviously you can figure out the distance is 2. So your distance is known. Now the only thing is like you have to figure out from here is like obviously you need to figure out the forces, right? So how do I multiply the force? It was Q1 Q2 divided by, I think it was 4 pi epsilon into r square. So how much is my charge? It's 10 to the power minus 6. What is my next charge? 2 into 10 to the power minus 6. And it was like 4 by 8.85 into 10 to the power minus 12. And the distance over here is given. So you basically use The distance is given over here, uh, which is 2 squared, and unfortunately you have to multiply with the distance again over here because work done is forced into distance. So you can basically say this one distance. So you can basically figure out your work done from here. Okay. So once you solve this, you would be able to figure out how much is your work done. Okay. How about we try to solve another question very similar to this one? So how about I stop sharing my screen? Again, I'll give you like 3 minutes for this one, not 5 minutes exactly, because we try to make you guys go a little faster than usual so that you can do the time management over here. So based on what I've taught you again, so they're asking you how many electrons can pass through a point on the conductor if the current is given and the time is given. So I'll work with you guys using my calculator. Give me 1 second. I usually just do it just stop working. We just share. Okay. Okay, okay. So I am pretty sure you're seeing the screen right now, the right one. Okay, just to make sure that you're seeing the right one. Okay. So the answer is this one, 3.125 into 10 to the 16, which if you had selected number B, uh, that was your right answer. Okay, so the right answer is B. If you already got a B, give a pat on the back. If not, it's okay. Let's learn where you guys made a mistake. Okay. So remember I told you every equation is there. So you basically have to use those equations and know where you have to apply. So we know current is what? Rate of flow of charge, right? So basically it's the charge divided by time. If you want to figure out, and remember, I emphasize that it's the coulomb, it's not the electrons that you measure, it's the coulombs that you measure, right? So 1 milliampere and the time was given like 5 seconds. So if you want to figure out the charge, you just cross multiply and you get like 5 into 10 to the minus 3 coulomb. Okay, now that's the charge. One electron has a charge of 1.6 into 10 to the minus 19 coulomb. Okay, so if one electron has 1.6 into 10 to the minus 19 coulomb, and you divide it by 5 into 10 to the minus 3, okay, so that's the total charge. And one electron, remember, one electron has a charge of 1.6 into 10 to the minus 19 coulomb. And since I already told you the total number of coulombs, which is 5 into 10 to the minus 3 coulomb, I can just do my reverse calculation and figure out how much electrons are there. So what I basically have to do is very simple, divide by the charge. For the charge for one electron, I would get to know exactly how much is the total number of charges. It's almost like doing a calculation for pens. Okay, so I got the perfect question. Start sharing the screen again. So now what we're trying to do is we're basically trying to figure out how much is the like potential difference if the distance is given 1 meter and the electric field strength is given 2000 volt per meter. Very straightforward, but I'll still give you like 3 minutes to figure it out, and then we'll just try to work it out. So let's try to solve this one. So this is a very straightforward question. They're basically asking you to figure out the potential difference given the distance between them and electric field strength. I'm pretty sure like you are very familiar with the equation, right? So this is the distance. They ask you how much is the potential difference. The distance is given to you 1 meter, and electric field strength is also already given like 2000 volt per meter, right? So obviously, you know the equation E equals to V by D. That's the equation that we are supposed to follow, right? So if this is 2000, and you basically have to find V, and the distance is given like 1, so you can basically say the voltage is like 2000. Okay, so it's actually A. So if you guys chose A, give yourself a pat in the back.